This video is on section 11.7. It's more on probability, specifically events involving the word and we will also look at conditional probability. We will probably need 2 videos for this material. When you see the word and, you're going to be talking about multiple events, picking several cards out of a deck of cards, flipping a coin several times. When you do an and situation, this multiple pick situation, we can have independent events or we can have dependent events. We'll look at dependent in a couple of screens. 2 events are independent events if the occurrence of either one of them has no effect on the probability of the other. Let's say you toss a coin 2 times. Does the result on the first flip influence your second flip? No. How about you toss a coin and then you roll a die? Does what happens on the coin influence what happened on the die? No. How about you roll a die twice? Does what happens on the first roll influence what happens on the second roll? No. So these are all examples of independent events. So a die is rolled and then a coin is tossed. Find the probability of rolling a number greater than 3 and then the coin landing on heads. Well, one way to do this problem, and I think it's a very long way to do it, is to list the entire sample space. Notice this is 1 followed by head, 1 followed by tail, 2 followed by head, 2 followed by tail, etc. We've got all of the sample space written out. So if I want to know what the probability is of getting a number greater than 3 and then heads, I just look at my list, a number greater than 3, that's from here on down, and then heads would be this, this, this. So that would be 3 out of the total number in my sample space, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which reduces to 1/4. And there's nothing wrong with that method, except if you have a very large sample space, you're going to be doing a whole lot of writing before you ever get to do the problem. So the better way when you're dealing with this word and is to use this very simple formula. If A and B are independent events, then the probability of A and B is just the probability of A times the probability of B. So the probability I will get a number greater than 3 would be to roll a 4, a 5, or a 6. So that's 3 out of 6. And the reason it's 6 is that we're rolling a die. There are 6 things that can happen on a die. Times heads. Well, if you flip a coin, it's either heads or tails, so your probability of getting heads is 1/2. And then you can multiply this up, which gives you 3/12, which reduces to 1/4. You can type it into your calculator. If you've got the fraction bar in the calculator, you can reduce. 3 goes into 6 twice, 1 on the top, 2 times 2 is 4. So you can use either method. It's just this is a lot faster than having to write out this big sample space. So we've got this, the probability that South Florida will be hit by a hurricane in any single year is 5/19. You can't see that very well. It's 5/19. What is the probability that South Florida will be hit by a hurricane in 4 consecutive years? Now, it doesn't say and, but it's what I call an implied and, because what it really means is what's the probability we'll get a hurricane, and then what's the probability we'll get a hurricane the next year, and then what's the probability we'll get a hurricane the next year, and what's the probability we'll get a hurricane the next year. It's just the product of those. So the probability that we will get a hurricane in any single year is 5/19. So it's 5/19 for the first year, for the second year, for the third year, for the fourth year, which is going to give me 5 to the 4th over 19 to the 4th. Now, do you have to write that out? No, it just depends on how you want to work your calculator. I think it's easier to enter on my calculator 5 to the 4th power than to have to type in 5 times 5 times 5 times 5. So 5 to the 4th is 625. And 19 to the 4th power is this, 130,321. Now that's my fraction. That says give a fraction answer, I've got that, and then give the decimal rounded to 4 places. This decimal rounded to 4 places is 0.0048. Now, same bit of information about this 5/19. What's the probability that South Florida will not be hit by a hurricane in 4 consecutive years? Well, the not is the opposite of this 5/19. The probability it will not be hit by a hurricane in any given years would be 14/19. And then 14/19 for the next year. and then 14 over 19 for the next year, 14 over 19 for the next year. Multiply that up using your powers or not, and we get this fraction, 38416 over 130,321, which is the decimal 0.2948. Now, a little more complicated is the question, what is the probability that South Florida will be hit by a hurricane at least once in the next 4 years? Well, you got to think about what at least once means. At least once means we get hit once, or we get hit twice, or we get hit 3 times, or we get hit 4 times. And remember, or means add. So to do it this way, I would have to figure out this probability. Then I'd have to figure out this probability. I'd have to figure out this probability. I'd have to figure out this probability and then add all of those up. That's okay. There's nothing wrong with that, but that's a whole lot of arithmetic you have to do. What we're going to use to do this using a formula is this fact right here. I'm going to explain to you where this fact came from, but this is where we want to go. The probability that an event will happen at least once is 1 minus the probability that the event doesn't happen. Now think about that. Back here on the hurricane, it could happen once or twice or 3 times or 4 times. The thing we didn't list here is not happening at all. And that's why we're going to use this formula. The probability that the event happens at least once is 1 minus the probability that the event doesn't happen. Here is the probability that we did not get a hurricane in 4 consecutive years. So that our answer here will be 1 minus that decimal, which was 0.2948. And that answer will be 0.7052. And that is the probability that we get this hurricane at least once in 4 years. Now, where did this formula come from? Well, we're going back to this right here. We know from a couple sections ago that the probability of not E is 1 minus the probability of E. The probability that something will not happen is 1 minus the probability it will. Remember this idea? The probability you will pass the next test is 1/3. So the probability you will fail the next test is 1 minus 1/3, which is 2/3. The probability it will rain is 70%. So the probability it will not rain is 1 minus 0.7, which is 0.3. We've used that fact before, so that's what this is. So getting it out of the lingo of E, let's talk specifically hurricanes. So the probability of no hurricane in 4 years equals 1 minus the probability of at least 1 hurricane in 4 years. The probability of no hurricane in 4 years is equal to 1 minus the probability of at least 1 hurricane in 4 years. All right, what I've done here is I have taken this statement and I've just abbreviated a little bit. I've written this as P of no H, that was no hurricane in 4 years, equals 1 minus P of H, meaning 1 hurricane in 4 years. I've got to do a little bit of algebra here, and the algebra I want to think about is this. Pretend this is X equals 1 minus Y. If you think back to your algebra days, this is solved for X, meaning X is alone. I need to rewrite this so that the Y stands alone. And the way I do this is I'm going to move the Y over here. And the reason I want to move the Y over here is that if you move something to the other side, you change its sign. So Y goes over here and becomes positive. At the same time, I want to bring the X over here, which makes this 1 minus X. So what I've done there is I've rewritten this so that the Y stands alone. Meaning with my hurricane stuff over here, this is now P of H, because I've moved that over here, equals 1 minus P of no H, which is what this says right here. The probability of at least 1 hurricane in 4 years equals 1 minus the probability of no hurricane in 4 years, which is this right here. The probability of it happening at least once is 1 minus the probability that it doesn't happen. You might not have followed this whole explanation, and that's okay. The important thing is you need to memorize that fact or write it on your card so that you can use it. The probability that the event happens at least once is 1 minus the probability that the event doesn't happen. Now, dependent events, two events are dependent events if the occurrence of one of them does have an effect on the probability of the other. So, dependent events are like drawing two cards and not replacing the first card. Independent event would have been we drew those two cards, but we replaced the first one before we drew the second one. So, if A and B are dependent events, the probability of A and B is P of A times P of B, assuming that A has occurred. I'll explain that as we do the arithmetic. It's still a multiplication. When you see the word and or and then, you're going to multiply. But watch the fractions. You are dealt two cards from a standard 52 card deck. Find the probability of getting two aces. So first off, the word and is not in there, but the probability of getting two aces is like saying, what's the probability of getting an ace and then getting an ace? So the probability of getting that first ace is 4 out of 52. We're not putting that card back. So how many cards are left in the deck? 51. Here's where this assuming that A has occurred comes into play. We are assuming because we wanted to get an ace, we're assuming we got that ace. So when I go to my next pick, there's no longer 4 aces. There are 3 aces. That's this assuming that A has occurred. So what you do here is you decrease the number in the numerator, you decrease the number in the denominator. If it's the same card you're trying to get, then use your calculator or reduce. I would reduce. This goes to 1/13. This goes to 1/17. And that gives me 1 over 221. If we were putting that card back, the probability of getting ace is 4 over 52. We put it back, so the deck is pristine. Probability of getting ace is still 4 because we put it back, and there's still 52 cards. So it's a different problem. That's why you have to read carefully about putting the card back or not. You draw one card from a 52 card deck. The card is not replaced in the deck, before you draw again. Find the probability of drawing an 8 the first time and a 4 the second time. Well, the probability of getting that 8 the first time is, how many 8s are there in the deck? There are 4 8s out of 52 cards. We are not putting the card back, so there are not 52 cards anymore. There's only 51 cards. What is the numerator here? We want to get the probability of a 4. How many 4s are there? There are 4. And you might be saying, wait a minute, why did we not decrease the numerator this time like we did on the last problem? Well, we are assuming that we got this 8. We got an 8 the first time. So the card sitting out on the table is an 8. We want to know the probability of getting a 4. There are still 4 4s. So then it's just a matter of reducing. 4 into here is 13. 1 times 4 is 4. 13 times 51 is 663. If this had been, we wanted the probability of getting an 8 and then getting an 8, it would be 4 over 52 times 3 over 51, because we wanted an 8 both times. It was the same card. When it's the same card, that's when the numerator decreases also.